Hi, welcome to our next level 3 probability distributions video, our fourth video for Poisson distribution. Right, we know Poisson distribution is often recognised by a rate. We're actually going to explore this idea in a little bit more depth this video. We have 4 conditions that must be met in order for us to use Poisson, and we are going to explore the last condition in our first example. The probability of an event occurring is proportional to the size of the interval. We also know that we have a parameter called lambda. It's the expected value or mean over a given time period. And in our second example in this video, we're going to introduce some new parameters for Poisson. All right, let's get straight into example 1. Over a term, a school has an average of 1.5 fire drills. So what is the probability a school has less than 8 fire drills in a given year? Right, so here are the 4 conditions, and we're going to explore this last idea because you can see that we have an average of 1.5 fire drills per term. The lambda is 1.5 per term, but the question is asking about the probability of having less than 8 fire drills in a given year. So we've got different intervals here. So let's explore this. We know if it's an average of 1.5 fire drills per term, we have 4 terms in the school year, so we can either add them up or we could multiply 1.5 times 4, and that will give us a new lambda. Lambda is on average 6 fire drills per year. So now we've got a new lambda. And so what we've done is we've looked at this idea of keeping the probability proportional to the size of the interval by changing our lambda. So we've changed the rate of 1.5 per term into 6 per year. Now we can go ahead and solve the problem. So let's get our calculator and go into Poisson distribution. We are selecting Poisson cumulative because we want to add up all the values less than 8. We're going into variable and we're going to enter in our parameters. Now for our lambda, which the calculator calls mu, I'm not a big fan of that, but for lambda we're going to put 6 because we're now talking about intervals per year. And for our x value, remember our calculator is set up to only add up all the probabilities less than or equal to a certain number. So when the question says less than 8, I want 7, 6, 5, 4, 3, 2, 1, and 0. So that's why I'm going to put x in, because the calculator will add up all the values from 7 and less. Right, we get a probability, which is the answer to our question. The probability of x being less than 8 fire drills in a given year is 0.7440, rounded to 4 significant figures. All right, we're going to move on to another example, a different idea. We're going to talk about how we can get some more parameters from Poisson, and we're going to show you how we can get the mean, variance, and standard deviation. Now, the expected value or mean is just lambda. That doesn't seem too hard because lambda is an average. But one thing that is a bit weird, variance is also lambda. And I'm not going to spend time in this video explaining why, but you need to just be aware that the variance is lambda. Now, this is provided on your formula sheet, which is a good starting point. And our standard deviation is the square root of lambda. All right, so let's get into our second example. It's the same one we've used in previous videos about our Pacific region. On average, 2.6 earthquakes that measure over 4 on the Richter scale per year. So let's calculate the expected value. Well, we don't need to because the expected value is just lambda. So the expected value, we've already got that information, 2.6. I've added that to my graph, by the way, just to visually represent it. Let's work out the variance, which the variance is also lambda. So the variance is also 2.6. And now we can work out our standard deviation. To do that, we square root the variance, or we square root lambda, and the square root of 2.6 gives us 1.612. I've rounded that to 4 significant figures. So those are some more parameters we can use and come up with from our Poisson distribution. Thanks for watching.